So let's try one more, a little bit more advanced. So one thing I notice here is I have a sine squared of theta, and I also have here a cosine of 2 theta. So those are all very different sort of trig functions. And I have to try to find some way to put everything together where I can get in terms of one trig function. So the idea that comes to mind is double angle formulas. So now when I look at these, I have 3 choices for cosine of 2 theta. There's this one here, and this one here. But if I notice, remember I have a sine squared of theta in this. So it would be nice to be able to use that idea. So what I'm going to do is I'm going to use this one here and see where that gets me. That has a sine squared in it, or I have a sine squared in my equation, so that's going to be perfect. So there it is. My substitution I actually put in red so you can actually see where it comes from and how it subs in. So everything else stays the same. So now essentially I'm just going to use some algebra and kind of put everything together. And since I have a squared there, I'm not going to worry about moving the 4 over anything. I just kind of want to put that together. So this is just going to be a 1 plus 4 sine squared theta equals 4. And one thing I kind of notice here is that I can actually move that 1 over. So subtract 1, subtract 1. So then I get 4 sine squared theta equals 3. Divide by 4, divide by 4. So I get sine squared theta equals 3/4. Then I have to square root both sides. And that gives me the sine of theta equals square root of 3. And don't forget your plus or minus here, because when you square root, it's plus or minus. Square root of 3 over 2. So now right away I'm thinking unit circles. So I kind of draw that out here. And then I say, okay, sine is going to be positive or negative. So do you know what that means? That means I'm essentially going to be in all 4 quadrants. So my first one means square root of 3 over 2, so that means opposite over hypotenuse. So I'm just going to go and do that all the way around. And this is what I end up with. Now I'm thinking angles here. So for this first angle, what's that first angle going to be? It's opposite the square root of 3, so that's going to be pi thirds. And then for the second one, remember now I'm going all the way around here. That's the angle I care about, not the reference angle. So the reference angle would be pi thirds. So this angle here is going to be 2 pi thirds. So that's my next one. And then the next one, as I go further around, that's going to be 4 pi thirds. And then I'm going to have to go even further around for the last one here, and that's going to be, generally go all the way around to 2 pi would be 6 pi thirds, right? Does that make sense? Okay, because if I divide that, it's just 2 pi. So I'm going 1 pi third less, so this is really 5 pi thirds. So those are the actual 4 answers for this. Now it says solve for theta. So that means I'm going to have to give all of the angles here. But one thing that's nice about this, I'm going to capitalize on the idea that I have symmetry here. Now what I mean by that is, take a look at this here. From here to here is pi. Would you guys agree with that? Yes, it's good. Okay, so that tells me then that I can write this as theta equals pi thirds plus pi k. And for the other angle, I can just use that 2 pi thirds in the same kind of way for the 5 pi thirds. So I can say the same thing here. Now, if you're not comfortable with that, you can just write out each one of them, and I would be fine with that as well on a test or quiz.